In this video, we'll be looking at the exponent properties and how to apply them. Here I have listed out all of the properties we use for exponents, and then we'll also do some quick examples of them, but I wanted to take a little bit of time to break down what some of them mean concept-wise. So the first one we have here is telling you that a variable raised to the 0 power is equal to 1. This is just something to know by definition. It's also helpful to know that if you have parentheses and inside the parentheses there are lots of numbers and variables being multiplied together or added, whatever, if they put to the 0 power outside the parentheses, then all of that stuff equals 1 anyways. So this is just a nice property to recognize because it really simplifies and eliminates a lot of the messy work. Next, we have a property that says a variable raised to a power that's multiplied by the same variable raised to a power means that you can just do the variable raised to the exponents added together. The most important comment I want to make on this one is you have to have a common base. That's why they use the same base of u for both of these two things being multiplied. But basically, if you see x to the second times x to the third, then your answer is x to the fifth. It's just telling you when can you add the exponents. It's only when you have a common base and the terms are being multiplied. Very closely tied to that property, if you have the same base, so x to a power and x to a power, it doesn't matter if the exponents are different, you subtract them. So the one on top minus the one on the bottom. So x to the fourth divided by x to the second is x to the 4 minus 2, which is the second. Now the second bullet and this fourth bullet are ones that are frequently confused. So I want to make sure you guys see the difference between these two. The first one is when you have two bases with exponents being multiplied together. This one, we only have one base being raised to a power, and then outside of the parentheses, there's another power. When this happens, you're actually multiplying the exponents together. So what confuses people, I think, is the fact that both of them have a multiplication operation in there somewhere. In this case, we're multiplying two bases. In this case, we're multiplying the exponents. So make sure you see the difference between that second and that fourth bullet. This one's actually pretty much the same thing. It's saying if you don't just have a single base being raised to a power, but you have two different bases. So the most common example for this would be having something like 3 times x, and then outside of the parentheses, you have the second or third, whatever power it is. This is just telling you that you can apply the exponent to both of the bases separately. What happens is a lot of people, if they have 2x raised to the third power, they don't apply the third power to the 2 as well as the x. So make sure you apply the exponent to every single base on the inside of the parentheses. Same thing for the property underneath it. This is just showing if you're not multiplying the two bases, but you're dividing the bases. It's the same thing. You need to take the exponent and apply it to the numerator and the denominator separately. And then probably the most frequently missed exponent properties, these two are essentially the same. Whenever you see a negative exponent, you take that base, that piece and that piece only, and you flip it either from the top of the fraction to the bottom, or if it was on the bottom of the fraction and it had a negative exponent, you flip it to the top. So denominator goes to numerator, numerator goes to denominator. The mistakes a lot of people make with these, they might have multiple expressions like 2 times x times y to the negative first power. Only the base that has the negative exponent gets flipped from the numerator to the denominator, not everything that's being multiplied together. So for that example, you would have 2x over y to the first power. Also, don't forget that when you do the flipping from the numerator to the denominator or vice versa, then you change the sign on the exponent. So it's no longer negative when you flip it to the opposite side. So now we'll look through some examples where these are coming into play, and I'll flip back and forth to the properties to show you which one I'm using along the way. So first we have a base raised to a power and a base raised to a power, and these two bases are being multiplied together. So the property I'm using is this here second one, and the property tells me that I need to add the exponents. So my answer in this case would be x to the 7th power. Notice that the base did not change, it's still x. The property just said to add the exponents. For number 2, we have y to a power and y to a power. So since it's the same base on both the numerator and the denominator, we want to recognize that this is a dividing question. So the property here tells me that when I have the same base being raised to different powers, I just need to subtract the exponents. The one on top minus the one on the bottom. So for number 2, you have y to the 8 minus 3, which is y to the 5th. Next, we have a base being raised to a power, and then outside of the parentheses, we have another power. So for a number raised to a power and outside of the parentheses another power, this property is telling me to just multiply those exponents together. So multiply the m and the n values. And again, I want to reiterate the important distinction between number 1 and number 3 here. These are the ones I see a lot of people confuse because in this case, we were multiplying the bases, but we added the exponents. In this case, we were multiplying the exponents. So we got the 12th power. Here we have two different bases. We have a base of x and a base of y. They have their own exponents, and then all that stuff is being raised to a different power. So the property I'm using is this one here. It didn't show an exponent on the u and the v, but that doesn't matter. This is just saying that you take that exponent and you apply it to each of the ones on the inside, and we're kind of combining it with this property. Since our bases might have an exponent, if I'm taking that exponent and raising it to another power, then wherever necessary, I will multiply those exponents together for each base. So what I've shown here is taking that 4th power and applying it to both of the bases separately. And then for each of those individual cases, since I had a power being raised to a power, it was important to remember to multiply those. So 2 times 4 was 8, and for the y's, 3 times 4 was 12. Next example, we're going to be doing essentially the same thing. I have stuff inside of parentheses, 2 different bases, x and 2. And then I'm going to take each of those exponents and apply the 3 to them separately by using this property listed right here. And just like on the last one, if either the numerator or the denominator had its own exponent, that would be fine. It would just mean I need to take the exponent on the outside and multiply it by those powers. So in the numerator, x to the 3rd power stays as x cubed, and 2 to the 3rd power, I went ahead and simplified. That's equal to 8. And then for the last and probably the trickiest one, the negative exponents. So again, let me remind you that the properties say only the bases that have a negative exponent will get flipped. Do not move other things, like the 2 is its own separate base. It's 2 to the 1st power times x to the negative 2nd power. So the flipping will just apply to the x's because anything in the numerator with a negative exponent goes to the bottom, and anything that's in the denominator with a negative exponent will flip to the top. And then don't forget to change those exponents to positive numbers once you flip them like that. So this example has things flipping from both numerator and denominator, but notice that everything else, like this 2, this 3, and this x, they stayed where they were. Now, the y to the negative 1st power flipped to the top to be y to the positive 1st, but you don't have to write numbers to the 1st power. That's why the 2 didn't have an exponent, or the 3 didn't have an exponent either. If something's being raised to the 1st power, just don't write an exponent, and that's what we assume. The other tricky thing that happened here was the x to the negative 2nd means x squared on the bottom, but I already had an x to the 1st down here. So I was using the property that says x to the 1st times x to the 2nd is x to the 3rd. So this is our final simplified answer for that number 6 example. And that's it for the notes on exponents. Thank you, guys.